In question 2 of this series, where we write equations for acid-base reactions involving strong acids, we're asked, write a molecular and a net ionic equation for the reaction that occurs between HBr, known as hydrobromic acid, and aqueous LiOH, lithium hydroxide. Let's start with the molecular equation. The molecular equation will be this plus this, forming a salt and water. So we have HBr plus LiOH, and both of these are in their aqueous state. And this yields a salt and water. Let's write down the water molecule, and it will be in its liquid state, plus our salt. Now, since water is being formed, that means this H and this OH are coming together somehow to form water. Our salt, therefore, will be bromine with lithium, and that forms lithium bromide. Let's see if our equation is balanced, and it has to be balanced moving forward. We have 2 hydrogens on the left side and 2 on the right side. We have 1 bromine on the left side, 1 on the right side. 1 lithium on the left side, 1 on the right side. And finally, 1 oxygen on both sides. So this is balanced. We don't need to do anything with that. Next, we need to write down our net ionic equation. And to do that, each of these compounds need to dissociate, except for the H2O that stays in its liquid state. Let's start with HBr. This becomes H plus, remaining in its aqueous state, plus Br minus, our anion. This becomes Li with the charge of 1 plus Aq plus 1 hydroxide ion. This is our polyatomic ion, and it stays as 1 unit with a charge of negative. This yields H2O, and I'm not going to break down H2O because it's in its liquid state. I only break down aqueous compounds. So I have H2O liquid plus Li1 plus aqueous plus Br1 minus aqueous. Now that I've written down the ionic equation, to write the net ionic equation, we have to get rid of the spectator ions. And what that means is you have to look on the left and the right side of this equation and see if there are any similarities, and if there are, you cross them out. For example, bromine ions will cancel out, lithium ions will cancel out, and this leaves us with H plus OH negative, and that produces H2O. H plus OH negative gives us H2O liquid. This is aqueous, and this represents our net ionic equation. There you have it. That is how to write equations for acid-base reactions involving a strong acid. In our next series, we'll do the exact same thing, but for weak acids.